Okay, there was one small topic which was left, so first I will do that. I will complete that part because stability will take more time. So this was just a simple thing which partially you have already seen in your Mass 1, Mass 2, how to, if you have a second order differential, at least for second order you must have seen how to reduce that to a first order system of equation if a second order differential equation is there. Anybody can tell me? Do you remember that? Hello? Anybody? Yes or no? Can anybody tell me?
No, sir.
A very simple thing is there. You have to, it does not matter whether it is a second order, third order, fourth order, or nth order. Anyone can be changed to that system of equations, and that's system of first order differential equation. That's the reason we have first seen that first order differential equation means y prime equal to f, and then we'll see that we can convert any order differential equation to first order system of differential equation, and we can apply the numerical methods which you have already studied. So let us see. I'm taking a little general problem type of thing. X square y double prime minus y prime plus 4x square y equal to 0. And the since it's a second order differential equation, so you require two conditions. So y1 is given, and then y prime 1 is given. Y1 is 1, y prime 1 is 2. Now let us put u1. We are introducing two variables, u1 and u2. If it is a nth order, we have to introduce n number of variables accordingly. So u1 is y, u2 is y prime. Then u1 prime is your u2. So first equation will be with this assumption, u1 prime will be your u2, and then u2 prime will be your y double prime, and then y double prime we can write from the equation, that is your x square y double prime minus y prime plus that. So from there we can write, so by dividing by x, you will get y double prime as 1 by x. Take other terms on the other side. So this will be y prime minus 4x minus 4 x square y. So that I mean, if you divide, it will be x. But if you take it as a common, so it will be 1 by x y prime minus 4 x square y. Now, y prime is u1, y prime is u2. So we'll replace this by u2, and 4x square y is your u1, so it is replaced by minus 4x square u1. So basically we get the system of equation of this type, u1 prime equal to u2, one equation, u2 prime equal to 1 by x, u2 minus 4x square u1. So this second order differential equation can be reduced to a first order system of differential equations, right? Basically it is a simultaneous in the sense that you cannot solve separately. Both the values will be calculated together. Means both the equations has to be solved together in one sense. So we have got this differential equation, u1 prime equal to u2, u2 prime equal to 1 by x, u2 minus 4x square u1, and then boundary conditions were given as, initial conditions were given as y1 equal to 1 means u1 equal to 1, y prime 1 equal to 2 means u1 equal to u2 1 equal to 2. So that's the reason you see u1 1 equal to 1, u2 1 equal to 2. Is this clear? Up to this, it is clear to everybody?
Yes, sir.
Okay. So if it is a nth order differential equation, you will write u1 equal to y, u2 equal to y prime, u3 equal to y double prime, u4 equal to y, like that. So go like that. You can reduce any order differential equation to your system, first order system of differential equation. If it is a second order, then there will be two components. If there are nth order, there will be n number of components. Is that clear?
Yes, sir.
Okay, so this we can write as a system of equations u1, u2 prime, that will be individual primes, and then on the other side I am writing a general one, f1 of x u1 u2. First one is also dependent on u1 and u2. Here only up to u2 only, but in general it may depend on u1 and u2. And then second one is also f2 x u1 u2. So one is f1 and another is f2, meaning by that both depends on u1, u2 and x. F1 of f1 will be u2 here, f2 will be the second part, that is 1 by x of u2 minus 4x square u1 with your initial conditions u1 u2 u1 u2 at 1 you may write as 1 and 2 vector, or you may write this as u1 1 equal to 1, u2 1 equal to 2. So we may write this u as a vector, u1 u2 transpose, f as a vector, f1 f2 transpose, and then we can simply write u prime equal to f. This is a vector equation. Is that clear? This is
Yes.
a vector equation. What I have written here is written here. This capital F has two components, f1 and f2. And then the vector u1 equal to 1 2, that vector 1 2 transpose, right? So any order differential equation can be reduced to first order system of differential equations. Is that clear?
Yes, sir.
Then after that, things are not difficult. Things are as it is. You know that Taylor's method, you know Euler's method. You have several methods in your hand. Now we'll just try to see the problems. Nothing more is there as far as the theory part is concerned. Use Taylor series method of order 2 for step-by-step integration of the differential equations. Here you see the two differential equations are given in a system of equations form. You make, if you proceed further, you differentiate them, you will find that this will reduce to second order differential equation. You can try the reverse way also. So u prime equal to xz plus 1 and z prime equal to minus of xy, y is, sorry, not u, y prime equal to xz plus 1, z prime equal to minus xy, y0 is 0, z0 is 1. Now you have to solve with your h equal to 0.1 and the range of x is from 0 to 0.2. So 0 to 0.2 means we have to subdivide the interval with h equal to 0.1, so 0, 0.1 and then 0.2. So x naught, x1 and x2, right? 3 points are there. Is that clear?
Yes, sir.
x2 is the 0.2 and then x naught is your 0, where the initial conditions are given. Now we'll apply the what is the Taylor's series method of second order. Means the up to h square, so yn plus 1 equal to yn plus h yn prime plus h square by 2 factorial or 2 yn double prime. Similarly for z, we'll write zn plus 1 equal to, I am writing it separately first, equal to zn plus h zn prime plus h square by 2 zn double prime. Is that clear? These are the Taylor expansion, Taylor series method for y and z. Is that clear?
Yes, sir.
Now here this y prime is there, y prime is available to you, y double prime is there, right? That you can get from here by differentiating y double prime, the first equation. Similarly, z prime you can get from here by differentiating the second equation. Once you differentiate this, here y prime will be there, here z prime will be there. That you can put it back, and then you can see that. So let me move further. So y double prime will be your xz plus 1. So that is your xz prime plus z. That is your x square. Z prime is put the value of z prime. So that will be, it will simplify that. You see this z prime is your x minus xy. So, sorry. Whether you are able to see the slide?
No, sir.
Oh, something happened. Something suddenly happened. Sharing was suddenly stopped automatically. Now you can see?
Yes, sir.
Okay. Why it is happened suddenly? Something funny is happening. I mean, morning I was not able to open the file, just like one day it happened. Then I tried the web version, then through that something happened, and then it started opening the file. Anyway, so so y double prime, we get that minus x square y plus z. Similarly, your z prime is there. In z prime, your it is your d by dx of z prime. So put the z prime and then differentiate that. Nothing is there. So z double prime equal to minus wherever y prime is there, you have replaced this by xz plus 1. That is the differential equation. Y prime is your xz plus 1 minus y, so it will become minus x squared z minus x minus y. So see, both the differential equations are here, which you require basically in the Taylor's method. Both the values of means y double prime and z double prime. Put it back and then see what is that we are getting. I require up to this much. Okay. So yn plus 1 equal to yn plus h yn prime plus h square by 2 yn double prime. Now yn plus 1 equal to yn h. Put the value of y prime. Y prime value is your xz plus 1. So this is written xn zn plus h square by 2 factorial. And then your y double prime is there. Y double prime value you have calculated. That is your minus x square y. So it will be minus x square yn. And then your plus your zn. Similarly, your yn plus 1 can be simplified like I'm just collecting the coefficients of yn, zn, and the remaining term. So yn coefficient is here and then here. So it is your 1 minus h square by 2 xn square into yn, and then zn coefficient. Zn coefficient will be hxn. So this is written hxn and then plus h square by 2 into zn plus one term is left, that is your h. Is that clear? Up to this it is clear? 1 prime up to
Yes.
equation number 1 prime it is clear?
Yes, sir.
Simply I have just simplified, nothing else I have done. Similarly, we'll write the second equation now. Zn plus 1 equal to, shall I explain this this equation also, or shall I move to the final one?
Move to the
Okay. So Zn plus 1 equal to minus h xn, that is the minus h square by 2 yn plus the coefficient of your Zn and minus remaining term, plus remaining term, that is your minus h square xn by 2. Now you see, you have the value x naught and y naught. Is that right?
Yes, sir.
Okay. So for n equal to 0, if you want to calculate your y1 and z1 together, so y1 will be what? Y1 will be this quantity, h is known, x naught is 0, so this is gone. So this is 1 into this is your y naught value is known, and this h into x naught, this is gone, so h by h square by 2 only, and then z naught, and then plus your h. Calculate this quickly, write down the value of x, your y naught as 0, write down the value of y naught as 0, z naught as 1. It is mentioned in the beginning, so I am just telling to you. Y naught is 0, z naught is 1. Have you written that?
It is 0.105.
What? Y1?
Yes, sir.
And then Z1?
Calculating, sir.
Other students? Other student? Mahika Matta? Mahika? Are you there? Mahika? Wait, I'm just talking to you. Naman Jaini? Jaini?
Yes, sir.
Naman?
Sir, I'm
So,
here.
calculating?
Yes, sir, I'm trying, sir. Like,
It is very simple. What do you mean by trying? Ankit Verma? Ankit Verma? Sawant Kumar Azad? So I'm just writing your names because you people are not there. You have just joined. Ankit Verma. Sawant Kumar Azad.
Yes, sir.
You are there. Okay.
Yes, sir.
Good. Rashmi Jain, are you there? Yashvi Jain. Yashvi Jain. Yashvi Jain. Are you there? Vardhan.
Yes, sir. Like Z1 is 1 and Y1 is 0.105.
That I will ask. Next. Wait. Let me see how many are just join and then Amit Kumar.
Yes, sir, I'm there.
Okay. Tanay Gaurav.
Yes, sir.
Gaurav.
I'm here.
Okay. Because you people are not maintaining honesty. Chinmay Jain.
Yes, sir.
There. Okay. Dipjoy Basak. Seems you are not there. Dipjoy Basak. PP Fahad.
Yes, sir.
Okay, you are there. Good. Dilip Khare. Bhargav Dilip Khare.
Yes, sir. I'm here.
Okay. Sai Kiran Nayak. So you are also not there. Okay. Bhagwati.
Yes, sir.
Okay. Hari Ganeshan. Hari Ganeshan. Hari Ganeshan. Hari Ganeshan. Jyotiraditya. Jyotiraditya Aryan. See these people. Jyotiraditya. Kavita. Kavita.
Yes, sir.
Okay.
Yes, sir.
Kumari Bhavna.
Yes, sir.
Okay. Lalit. Lalit.
Yes, sir.
Okay. I think his first name is Leo. Leo. Leo Lawrence. Leo Lawrence. Okay. Mausam Sinha.
Yes, sir.
Okay. Oh, people are joining continuously. See from where they are coming. Your attendance, I have already taken the attendance. So even if you join now, it has no meaning. Those who are joining now. Nidhi Raj,
Yes, sir.
Pooja Sharma, Pooja
Yes,
Sharma.
sir. Yes, sir.
Okay. Padma Shri, Padma
Yes,
Shri,
sir. Yes, sir.
People Hearts, People Hearts, Rahul, Rahul Kumawat,
Yes, sir.
Rahul, okay.
Yes, sir.
Rishabh Kumar, Rishabh Kumar, Rishabh Kumar. Okay, today for today these many attendance are fine. Okay, so what are the values you are getting for Y1 and Z1?
Y1 is 0.105, Z1 is 1.
Z1 is 1. That's right. So now you can go for Y2, Z2. What about others? What about others? At least those who said that they are present. I want the answer from other people also. I want answer from other people also quickly. For Y2 and Z2.
Sir, Y2 is 0.219999475.
Y2 is how much?
0.21
0.21.
triple 9,475.
No, some mistake is there. It's a very simple calculation. Cannot be triple line.
Sir, it is 0.219475.
That's right. And then Z2.
Z2 is point. It has two nines. 0.997875.
That's it. That's it. So what about others? Only two people told me this. What about others? What about others? Otherwise, I will call by name now. Quickly. Otherwise, I will call by name.
Sir, Y2 is 0.219999475.
Y2 is 0.
219999475.
No, that is not correct. Who is telling?
Sir, Sneh.
No, it is not correct. Should be
Sir, Y2 is
0.219.
0.20504475.
Which one? Which one you are telling? Which one?
Y2. Sir, Y2.
Y2 is not correct. Check it. It's a very simple calculation where you are doing the mistake. 0.1 is square, 0.1 is square. Where is the mistake?
Sir, I'm again getting that y2 as 0.21999475.
So you are, it is something happen. It is happening like that. That 2 into 2 you are writing as 5. Somewhere you are doing like this type of mistake, because it is very simple. All the digits are just 0.1. It's a square divided by 2 multiplied by, and so on and so forth. That's all. Nothing else is there.
But sir, I've done again by calculator. It is 0.21999475.
Check it
I am
again.
also getting 0.21999475.
You have taken the value. Okay, I am showing the calculation. Just check it.
Yes, sir. 0.21999.
So where is the mistake then? You say, see, y2 is calculated here. See.
So up to third digit, it is correct. Like 0.219. Then we are getting not 475.
No, it is very simple calculation. It cannot have this much of the difference. You see the digits. Right? See the digit. So verify that. Right? Snehbandhu?
Okay, sir.
You just verify. Don't waste time here. Other people also check that where is the mistake, or I don't think that there is any error in this one. I doubt. You just calculate whatever I have written here. Whatever I have written here. Snehbandhu?
Sir, I have calculated it is again coming 0.219994.
That's what I am saying. Na? If some mistake you are doing, 2 is to 2 is 5, so you will do that is the same mistake. Na? So just verify after the class.
Yes, sir.
It is just a matter of calculation where the mistake is happening. Right? Maybe some values you are missing, or some values are extra is there. Something of that kind might be happening. Okay, so this next problem I can leave. That is your y prime equal to xz plus 1 and z prime equal to minus xy. Apply Euler method. So Euler method will be yn plus 1 equal to yn plus h times f. F is for this f is this side, and then you have already seen how to apply that, right? And similarly you write for zn plus 1, and then you start calculating for n equal to 0. So first you get that y1, then you get z1. Unless until both are, you cannot do that. You calculate all the values of yn. You cannot calculate, because you see zn is also coming in the picture. So maybe y1 you can calculate because z0 is available. But then unless until your z1 is available, you cannot calculate your y2. Is that right?
Yes,
unless
sir.
until your z1 is available, you cannot calculate your y2, right? Right?
Yes.
So here it is, I have written in a vector form, so that because that you cannot write every time, because yn plus 1 equal to yn plus hxn zn plus 1, and zn plus 1 equal to zn minus hxn yn. So yn plus 1, zn plus 1, and then y, it is written in the that matrix form, Ax equal to b type of thing. So y and zn coefficients are there. I have written like this, plus the extra terms are there, constant terms type of thing. And then every time this portion you have to calculate, right? So, and then immediately you can write down the value. So I'm leaving at this stage. Next is the your Runge-Kutta type of method. How will you apply the Runge-Kutta? Have you done any problem using your fourth order Runge-Kutta method?
No, sir.
Fourth order Runge-Kutta method I have already told, I think. Yes or no?
Yes, sir.
Yes or no?
Yes, sir.
Okay. I think one problem is there with the single variable. Let me see. Here, you may note down this problem. Note down this problem on your register. If you see this slide, means everything is done, so that has no meaning. Wrote out this problem. Use the classical Runge-Kutta method of fourth order to find the numerical solution at the point x equal to 0.8 for y prime equal to square root of x plus y. Y.4 is 0.41. Assume the step length h as 0.2. So means it is 0.4, then 0.6, and then 0.8. There are 3 points, right? K1, it is your 1 by 6. Let me check. 1 by 6 K1 plus 2K2 plus 2K3 plus K4. Correct. It is written correctly. You see the 2 plus 2 plus 1 plus 1. So total is 6 divided by 6. It normally distributed like this. So so K1 is given, K2 is given, K3 is given, K4 is given, right? This is just a single equation. This is just a single equation. So there is no trouble. You can calculate K1, you can calculate K2, you can calculate K3, K4 with your X0, and then means K1 at the point, if you want to take J equal to 0, then it will be your y1 equal to y0 plus, here the ki's will be calculated at the point x0, means k1 will be h into f of x0 y0. Next k2 will be h into f x0 plus h by 2 y0 plus k1 by 2, and like that. Is that clear?
Yes, sir.
Okay, so I'm leaving this as an exercise. You should have done that because it was already told to you, so you should have done the problem. So one problem is here. Unless until you understand this, you cannot proceed further. So is there any query from anybody for this single equation? Is there any trouble in calculating K1, K2, K3, K4 for this single equation? Anybody? Anybody has any trouble? Anybody? Yes or no?
No, sir.
No, you are the only person responding. What about the others? What about the others? Yes.
No, sir. No, sir.
Okay, good. So then I will go for the simultaneous equations, or the apply Euler method. Okay. This you have to understand a bit. A bit of difference is there. Here it was a mistake. So I will tell the correction. Find the solution of the system of equations y prime equal to u and u prime equal to minus 4 y minus 2 u. The conditions are given as y0 is 1, u0 is 1 by Runge-Kutta method of fourth order with h equal to 0.1, and then you have to find 0.2, y.2 and u.2. We have to just understand. Here there is one error. It should have been 1 by 6 K1 plus K2 plus 2K3. You please note down this correction. It should be 2K3 plus K4. Here also UN plus 1 equal to UN plus 1 by 6 L1 corresponding to KIs, L1 plus 2L2 plus 2L3 plus L4. This is not 3, this is 2 with the K3s and L3, right? Have you noted down?
Yes, sir.
Okay. So, you see, you have, in general, if I see that there are two equations, y prime equal to f x y u. It depends on y as well as u, both. For example, you see the second one. U prime depends on y and u both. So Here it is a particular one that it does not depend on y. It may depend on y, it may not depend. But in general, I am writing y prime equal to f of x, y, u. Means f is this quantity, here it is u only. For the second one, u prime equal to g of x, y, u. Right? That is your g is your minus 4y minus 2u. Is that clear?
Yes, sir.
Okay. Now, if you see this fourth order one for single equation, K1 was h of f xj yj. Only yj is there. Similarly, here only yj is there. Here also K3 yj is there. Here also only yj is there because it was a there were only single equation. Is that right? In y.
Yes, sir.
Okay. Now I will just come back to this one. Here there are two equations. Y prime equal to f, u prime equal to g. Now, means that h into f is there, h into g is also there. The two types of slope are there. Is that right?
Yes, sir.
So we have to modify this fourth order Runge-Kutta method, which will be done like this. K1 will be h times f of, since it depends on x, y and u both. So y and u both, so f of xn, yn, un, right? One extra component is added. If there are three equations, then one more will be added. Is that right?
Yes, sir.
Okay, then K2 will be h f of xn plus h by 2, and the in the first only just single equation you have yn plus 1 by 2 of K1. Here we will have un plus 1 by 2 of L1 also. Corresponding to u, L is there. Corresponding to u, L is there. I will write L also. Right?
Yes, sir.
Okay. Then K3 accordingly, xn plus h by 2, yn plus k by 2, un plus 1 by 2 of L2. So corresponding to u, we have L. Corresponding to y, we have k. And similarly, K4 will be h of h times f of xn plus h, yn plus k3, un plus L3. Now, how these things will be there? U prime equal to G. Corresponding to your y, the slope was f, so it is written in terms of f. Now, L1 will be h times, and corresponding to u, the slope is your g, so it is written in terms of g. L1 will be h of g of xn, yn, un. And then L2 will be h of g of xn, h by 2 plus the second component yn plus k1 by 2, un plus L1 by 2, right? The only difference is that it is replaced by g, because the slope corresponding to your the second equation u is your g. Is that right?
Yes, sir.
Okay. L3 is again written exactly like that. The only difference is that it is replaced by G. L4 is also written like this. Now you see one thing. You have to calculate K1, then L1, K2, then L2, K3, then L3, and then K4, then L4. Otherwise you won't be, because if you see the first one, n equal to 0, K1 will be h, fx naught, y naught, u naught. And then you have to here if you go, K2 will be h f of x naught plus h by 2, y naught plus k1 by 2, and u naught plus L1 by 2. So unless until you calculate L1 at this stage, at K1 stage, you don't have the value at this stage. So you have to calculate your L1. So first we will calculate the value of K1, then L1, and then for next one K2, then L2, and then K3. You cannot calculate K2 from K2 to K3 directly. And then similarly, further you have to calculate both these values together. Is that right?
Yes, sir.
Okay. So if you see that f is given as u, g is given as -4u minus 2u, so we'll write k1 as h times un. L1 immediately is written. As soon as we have calculated k1, immediately L1 is written. H times, because it is your this quantity, g is this, so h times minus yn minus un. First part is clear? L1 and k1?
Yes, sir.
Okay. Once you have calculated L1 and K1, then only you can go for K2, because K2 requires your K1 also, it requires your L1 also in general. Fortunately, here only L1 is required, but without L1 you cannot proceed further. So, so K2 can be written, I am not telling the simplification. So K2 can be written in this form by putting the values of your K1 and L1. Is that right?
Yes, sir.
Okay. Then for L2, unless until you would have calculated your okay, I mean that L2 has to be calculated. K2 we have calculated, L2 we have to calculate. Exactly the same way, your K1 you can put, L1 is also available, you can put the value, simplify that, and then you get that L2 is your this quantity. Next, you go for K3. First you calculate K3, then you calculate
L3.
L3, right? And then similarly you go for K4 and then L4. Once all these are available, then only you can proceed further, right? So then put all these values that your method has, the fourth order method, that yn plus 1 equal to yn plus 1 by 6 k1 plus 2k2 plus 2k3 plus k4 and then un. So once you put it is, I mean, fortunately it can be written in, it can be written in terms of your vector form, but not every time it is possible. So wherever it is possible, you can use that vector form. Where is that one? See, yn plus 1 written in terms of yn and un plus 1 after simplification written after putting all the values k1, k2, l1, l2 and all those things. So it is written as un plus 1 equal to yn, and then in terms of yn and un. So we write the yn plus 1, un plus 1 in the matrix form. I think you can write without any trouble, or anybody has any trouble to write in the matrix form. Here the vector is your u1, y1, yn, un. Then you see the coefficient of this yn is this in the first equation. So here from here you'll see yn plus 1 equal to this quantity into yn, this quantity into un, and then your for the second equation un plus 1, this quantity into yn. So this quantity is the same one, it is written into yn, and then this quantity into un, right? Is that clear?
Yes, sir.
Okay, so this value h is fixed, so this value is always, this matrix is always fixed. This may not happen every time. This may not happen. Wherever it happens, you can use make use of that. So h is fixed. So this quantity, this matrix entries are fixed. So basically, you put y naught is 1, u naught is 1, and then immediately you will get. So find the value of your u1, y1, u1 quickly. Everything is written here. Quickly find out. Quickly find out. So what is y1 and what is u1? So very simple. Why you are taking this much of time? You are able to hear me?
Yes, sir.
Okay. Rishigirish?
Yes, sir.
Tell me the value. Y1
Y
and U1.
Y1 is 1.07136 and
That's
U1
right.
is 0.44114.
That's right. Similarly, you can find out y2 and u2. So it becomes simple once, but it is not possible every time to write in this form. It is not possible every time. Quickly tell the value of y2 and u2. Sagun is there. Sagun? Sagun? Hello? Sagun is there? Okay, I could yeah, understood. Samira Yashmin?
Yes, sir.
Okay. So could you understand what I have said?
Yes, sir.
Okay. But you are not telling the values. Tell me y2 and u2 quickly.
Sir, actually, I joined a little late because of internet connectivity issues.
Oh, that anyway, if you are genuinely saying fine,
Sir, I'll see the recording of today's class.
you are
Sir, I'll see the recording of today's class.
okay. You see, problem with me is that I cannot watch every time you people. The only thing I expect that you people are matured enough to be honest, and that is the point. Because if you are not honest, you are uh, missing something, and you are the problem will be to you, not to me. Is that right? Those who are just joining and not at all available there. So, yes, Rishi Kumar, what is the value of y2 and u2? Rishi Giris? Yes, Snehbandhu?
It's so white is 1.09.
And then u2?
1.09.
u2?
Sir, U2 is minus 0.032356629.
Good. So, in the meanwhile, since a bit of time is still there, so you do one thing. Now it is clear. You can there won't be any trouble. So you just apply this fourth order method to the problem which I was telling. You can calculate K1, K2, K3 and K4 quickly. Now you have done the advanced part, that is your two variables. Quickly find at least K1, K2, K3, K4 for this problem. Problem is seen on your screen. Snehbandhu? Snehbandhu? Hello? Hello.
Yes, sir.
My voice is going? You are able to hear?
Hello. Yes, sir.
Okay. So
Hello.
just do that problem which I have told you people to, as an exercise. So you can start doing this here. At least find out the value of K1, K2, K3, K4 quickly. F is that your square root of x plus y. Quickly find out. I want to see how many people can tell me at least K1, K2, K3, K4. Acha, did you get that mail? Pardon me?
K1 is 0.18.
Good, very good. Did you get the mail regarding your exam and syllabus?
Yes, sir.
Good. And K2 value, K1 one student has told that 0.18. You have to use calculator.
Sir, K2 is 0.2.
Exactly, correct.
Sir, K3 is 0.2009975.
K3 is K3 or K4?
0.200.
You are
Sir,
telling K3 or
K3.
K3 is 0.2 double
Double
zero
zero
9975,
9975.
and then K4
K4 is 0.22000906.
correct. So now you put all the values. So y1 is your y0 plus 1 by 6 K1 plus 2 K2 plus 2 K3 plus K4. You can get to y1 quickly. Y1 will be y0 plus 1 by 6 K1 plus 2 K2 plus 2 K3 plus K4. So y1 is available quickly. That is your y.6. Anybody got the value of y1? At least the person who has got the all the ki's K1 to K4.
So y1 is 0.6103476.
Tell again, your voice is quite low. Tell me.
0.6103476.
0.6103476. That's correct. Correct. So now you can understand that how you have to solve the single equation and then how you have to solve the system of equations. And any order differential equation can be reduced to system of first order differential equation. Is that right? And then you can apply those methods on that. The only thing it may be you have to a little bit modify the method depending on the situation. Is that right? Is that right?
Yes,
Yes,
sir.
sir.
Okay. So anything which is not clear for today's thing, you can ask me. Anything which is not clear? Snehabandhu?
So only that part, like the equations, like the matrix we have formed, like it is not necessary that it will be the first matrix will come constant always.
No, it is not necessary. It is not necessary. Depends on the situation. If it comes, you can make use of that.
Okay, sir.
It is not necessary that you will get that. If it comes like that, you make use of that. If it is not, because we have seen only few methods: Taylor series method, Euler method, and then your Runge-Kutta method. So if it doesn't come, then you have to see accordingly.
Then it will become a long problem then.
Yeah, obviously. Means you have to do it individually.
Yes, sir.
Any other query from anybody? Any other query from anybody? Okay, then for today I am just closing, and then your stability again I will take up on this Saturday, right?
Okay, sir.
Okay, fine.
Thank you.
Thank you.
Thank you, sir.